Installing a 100-watt high-pressure sodium bulb in a 277-volt 250-watt fixture is generally not recommended. The fixtures are designed for 250-watt bulbs, which draw a specific amount of current. Using lower wattage bulbs can change the current flow through the fixture, potentially leading to overheating and damage. The fixtures are designed for a specific wattage for a reason. The components inside the fixture are rated to that wattage. When using a low wattage bulb, that means there is extra headroom as far as wattage goes, but that does not translate into the fixture lasting longer. The reason being is that the fixture has components that may require a minimum amount of wattage to function as expected. Think of it like an engine, and the 250-watt bulb being like the correct amount of oil flowing through the engine. If you reduce the amount of oil flowing through the engine, then the engine will not be lubricated enough and cause damage to the engine. The same thing applies here in this scenario, where some of the components will not operate correctly, which can damage the ballast, capacitor or igniter. If you want the fixture to last, it is best to use the correct wattage bulb. A 100-watt bulb will produce less light output compared to 250-watt bulbs, which can impact the effectiveness of the lighting system. You may not have enough light for the area you are trying to illuminate. Operating bulbs at a lower voltage than their rated voltage can reduce their lifespan. Using bulbs that do not match the fixture's specifications may void the fixture's warranty. To ensure optimal performance and safety, it is recommended to use 250-watt HPS bulbs in the 277-volt fixtures. If you wish to reduce power consumption, consider the following options. Firstly, use a different bulb type. Replace the high-pressure sodium bulbs with light-emitting diode fixtures, which consume significantly less energy while providing similar or better light output. Light-emitting diodes are more efficient and use less energy to produce the same amount of light. Secondly, install dimmers. Dimmers can be used to reduce the power output of the high-pressure sodium bulbs, but it is important to ensure that the dimmer is compatible with the fixtures and bulbs. Not all dimmers are created equal. Some dimmers are designed for incandescent bulbs, while others are designed for fluorescent bulbs, and even others are designed for light-emitting diode bulbs. Make sure you choose a dimmer that is compatible with the type of bulb you are using. Dimmers work by reducing the amount of voltage that is supplied to the bulb. This will reduce the amount of light that the bulb emits, and it will also reduce the amount of energy that the bulb consumes. Thirdly, install occupancy sensors. Occupancy sensors can be used to turn off the lights when the area is unoccupied, reducing energy consumption. Occupancy sensors work by detecting motion in a room. When motion is detected, the sensor will turn on the lights. When no motion is detected for a certain period of time, the sensor will turn off the lights. This can save a significant amount of energy, especially in areas that are not used frequently. The sensors use various technologies such as ultrasonic, infrared, or microwave to detect occupancy. Ultrasonic sensors emit high-frequency sound waves and measure the reflections to detect movement. Infrared sensors detect changes in heat signatures. Microwave sensors emit microwave radiation and detect changes in the reflected signal. When selecting an occupancy sensor, consider the coverage area, mounting location, and sensitivity adjustments. Some sensors also offer features like adjustable time delays before turning off the lights and daylight harvesting, which adjusts the light level based on the amount of natural light available. This further reduces energy consumption by dimming the lights when sufficient daylight is present. Another option is to use timers. Timers are devices that can be programmed to turn lights on and off at specific times. They are commonly used in outdoor lighting applications but can also be used indoors. Timers are a simple and cost-effective way to control lighting schedules. There are two main types of timers: mechanical and digital. Mechanical timers use a dial with pins that can be set to turn the lights on and off at specific times. Digital timers are more advanced and offer greater flexibility in programming. They can be programmed to turn the lights on and off at multiple times throughout the day or week. Digital timers also often have features like automatic daylight saving time adjustment and battery backup in case of power outages. When installing a timer, it is important to choose one that is rated for the correct voltage and amperage of the lighting circuit. It is also important to follow the manufacturer's instructions carefully to ensure that the timer is installed correctly. A further option is to use photocells. Photocell sensors, also known as photoelectric sensors, are light-sensitive devices that automatically turn lights on and off based on the ambient light level. These sensors are commonly used in streetlights, parking lot lights, and other outdoor lighting applications. Photocell sensors work by measuring the amount of light that falls on a light-sensitive component. When the light level drops below a certain threshold, the sensor turns on the lights. When the light level rises above a certain threshold, the sensor turns off the lights. The threshold is adjustable to suit the specific application. There are two main types of photocell sensors: thermal and electronic. Thermal photocell sensors use a bimetallic strip that bends in response to changes in temperature. When the light level drops, the bimetallic strip cools and bends, closing a switch that turns on the lights. Electronic photocell sensors use a photodiode or phototransistor to measure the light level. When the light level drops, the photodiode or phototransistor conducts less current, which triggers a switch that turns on the lights. Photocell sensors are a simple and reliable way to control lighting based on the ambient light level. They can save energy by ensuring that lights are only on when they are needed. When installing a photocell sensor, it is important to choose a location where it will not be shaded by trees or buildings. It is also important to adjust the threshold to suit the specific application. Furthermore, consider using smart lighting controls. Smart lighting control systems offer advanced features for managing and optimizing lighting in buildings. These systems typically consist of a central controller, smart light fixtures, and various sensors and switches. The central controller allows users to program lighting schedules, set light levels, and monitor energy consumption. Smart light fixtures have built-in microprocessors that allow them to be individually controlled. They can be dimmed, turned on and off, and even change color. Sensors can be used to detect occupancy, daylight levels, and other environmental conditions. This information can be used to automatically adjust the lighting to optimize energy efficiency and comfort. Smart lighting control systems can be integrated with other building management systems, such as heating, ventilation, and air conditioning, to further improve energy efficiency. Smart lighting control systems can be expensive to install, but they can provide significant energy savings over time. They can also improve the comfort and productivity of occupants. When selecting a smart lighting control system, it is important to consider the size and complexity of the building, the types of lighting fixtures used, and the desired level of control. In addition to these technologies, the design and layout of the lighting system can also have a significant impact on energy efficiency. For example, using light-colored surfaces can reflect more light and reduce the need for artificial lighting. Positioning light fixtures strategically can also improve lighting uniformity and reduce glare. Lighting maintenance is also important. Regularly cleaning light fixtures and replacing burnt-out bulbs can ensure that the lighting system is operating at its full potential. Over time, dust and dirt can accumulate on light fixtures, reducing their light output. Burned-out bulbs should be replaced promptly to maintain the desired light level. When replacing bulbs, it is important to choose energy-efficient options, such as light-emitting diode bulbs. These bulbs use significantly less energy than incandescent bulbs and have a much longer lifespan. They are also available in a variety of colors and light levels, so it is easy to find one that meets your needs. When designing a lighting system, it is important to consider the specific needs of the space. For example, an office space will have different lighting requirements than a warehouse. Office spaces typically require bright, uniform lighting to promote productivity. Warehouses typically require less intense lighting, but it is important to ensure that there is adequate lighting for safety. In conclusion, there are many ways to reduce power consumption in lighting systems. By using energy-efficient light fixtures, installing dimmers and occupancy sensors, and designing the lighting system carefully, it is possible to save a significant amount of energy. Another factor to consider is the color temperature of the light. Color temperature is a measure of the color of light measured in Kelvin. Lower color temperatures, such as 2700 Kelvin, produce a warm, yellowish light, while higher color temperatures, such as 5000 Kelvin, produce a cool, bluish light. The ideal color temperature for a space depends on the intended use of the space. Warm light is typically preferred in residential spaces, as it creates a cozy and inviting atmosphere. Cool light is typically preferred in office spaces and other work environments, as it can improve alertness and productivity. The color rendering index is a measure of how accurately a light source renders colors. A light source with a high color rendering index will render colors more accurately than a light source with a low color rendering index. The color rendering index is measured on a scale of 0 to 100. A color rendering index of 100 indicates that the light source renders colors perfectly. The human eye is more sensitive to light in the green region of the spectrum. This is why green is often used in emergency lighting applications. The color of light can also affect our mood and emotions. Warm colors, such as red and orange, can be energizing and stimulating. Cool colors, such as blue and green, can be calming and relaxing. The angle at which light strikes a surface can also affect how we perceive the light. Light that strikes a surface at a shallow angle will be more likely to be reflected, while light that strikes a surface at a steep angle will be more likely to be absorbed. The type of finish on a surface can also affect how light is reflected. Glossy surfaces will reflect more light than matte surfaces. The size of a light source can also affect how we perceive the light. Small light sources will produce more glare than large light sources. The distance between a light source and a surface can also affect how we perceive the light. Light that is closer to a surface will be brighter than light that is farther away from a surface. The amount of light that is needed in a space depends on the task that is being performed in the space. Tasks that require high levels of detail, such as reading and writing, will require more light than tasks that do not require high levels of detail, such as walking and talking. The age of the occupants of a space can also affect the amount of light that is needed. Older people typically need more light than younger people. The health of the occupants of a space can also affect the amount of light that is needed. People with certain medical conditions, such as macular degeneration, may need more light than people without those conditions. The type of lighting control system that is used in a space can also affect the amount of light that is needed. Lighting control systems that allow users to adjust the light level can reduce the need for excessive lighting. The amount of daylight that is available in a space can also affect the amount of artificial light that is needed. Spaces that have access to natural light may not need as much artificial light. The location of a space can also affect the amount of light that is needed. Spaces that are located in areas with high levels of ambient light may not need as much artificial light. The time of day can also affect the amount of light that is needed. Spaces that are used during the day may not need as much artificial light as spaces that are used at night. The season of the year can also affect the amount of light that is needed. Spaces that are used during the winter may need more artificial light than spaces that are used during the summer.